Good afternoon. I'm Zhao Yiyang from China. The topic of my chemical research is BIOMIMETIC synthesis of natural chromophoric phenoxane compounds. Let's begin the introduction through video presentation.
Hello, I'm Zhao Yiyang from Henan Experimental Middle School. My tutor is Professor Yang Guanyu from Zhengzhou University.
I fall in love with chemistry as early as 10 years old, and personally conduct basic experiments and collected 80 kinds of elements. I conducted chemical experiment activities at my home, independently get a variety of compounds. Also, I personally collected 80 kinds of chemical elements.
In 2020, I grasped a research opportunity to join in an in-China project. When Professor Yang told me about the project of BIOMIMETIC synthesis, it arouses my great enthusiasm. Without hesitation, I participated in it.
Now, I feel it a privilege to participate in the international online forum of scientific youth. Hope to communicate and make progress together in the forum. APXOs are widespread natural compounds, which was used as dye in ancient time and later developed as probes for bioimaging in modern days. APXO diversities are reported to demonstrate bioactivities to be used for the treatment of cancer, bacterial infection, and other diseases. Developing enzyme-mimicking catalytic models with a more cost-effective means of synthesis continues to be a great challenge. Sustainable technologies are still required with respect to environmental concerns, safety, cost, physical workup, and practical industrial application. Hurrying to pursue a green and sustainable enzyme-liking approach for synthesizing APXOs. A Lucky's mimicking model with natural gallic acid and manganese acetate was developed. As for the methods, I use Isaiah Finder and Web of Science to search and read literatures, ChemDraw and Origin Softs for drawing structures and reaction formula, catalytic experiments to study the catalytic for performance and optimize reaction conditions, reaction analysis with TLC and HPLC, purify our products by recrystallizations.
Yang, we can hear you. Yang. Hello. Yang, should it be any sound in your presentation? We can see your screen, but cannot hear you. Or sound. I have resent the instructions of how to share sound on Zoom. Should it be any sound in your video? Yiyang.
hear me now?
Yeah, we can hear you.
Can you hear this video?
The reactor was heated to 25.
It's good then.
Okay. May I replay this video again? Sorry.
Play from now. I don't think we missed too much. Play from
We
now.
are ready to continue watching your video.
Play from now.
Play from now. Okay.
And keep the pressure of oxygen and 0.3 megapascal for the deserved reaction time. The ending reaction mixture was acidated to pH 1 to 2. In the end, solid cake was washed with water for 3 times. To improve my comprehensive ability in practice, I assisted in group research and learned necessary knowledge. First, we conduct thermodynamism and achieved a yield of 99%. Then, we use in-situ UV kinetic investigation and draw a curve of initial speed against the concentration, which confirms the measurement kinetics supporting a likely mimicking behavior. My teacher told me this is a plausible mechanism of it. On top of that, we developed cross-color condensation with a yield of 98%. Through the above project research, I grasped the experimental skills and related knowledge. I wonder if it can process polycondensation, so I began my interest in several research interim. I conducted several tests to optimize the conditions and obtained a brown-rice black compound with 70% yield. However, as special structure and possibilities, I still can't confirm its structure by HNMI and HPLC, but I find out its more clear weight in the HRMS, in spite of about 0.198% error. So this means I got a target compound, and the synthesis method has its possibility and feasibility. I will conduct further research on polycondensation as soon as possible. To conclude, a green, convenience, and biomimetic method for the preparation of phenoxazine compounds was developed. The demeritations occurred by using natural renewable gallic acid, magnesium acetate, oxygen as oxidant, and water as solvent. The method with practical convenience and low loading of catalysts opens the door for future development. During my study and research, first, I learned lots of chemical experimental skills and knowledge. Second, I used an advanced method to conduct further study and achieve initial success. Next, I will continue my study and learn professional knowledge actively. I believe my research will get more success sooner or later.
Luckily, Our project has published in journal Chemical Select recently. As for the reason why we choose this project, APXOs are widespread natural compounds which was used at dyeing ancient time and later developed as proof for bioimaging in modern days. We developed enzyme mimicking catalytic models with the most cost-effective means of synthesis continue to be a great challenge. Hurrying to pursue a green and sustainable enzyme lacking approach for synthesizing APXOs, we developed this lattice mimicking model. I use as a funder Web of Science, ChemDraw, OriginSoft, catalytic experiments, TLC, HPLC, purifier plugs by recrystallization, NMR, HRMS, to carry out my research. And we process our reaction in a pressure tube with 2 aminophenol, gallic acid, manganese acetate, and water. The mixture was adjusted pH to 9. After the reactor closed, the mixture was changed with oxygen for 3 times. Then the reactor was heated to 25 degrees, and the pressure of oxygen and 0.3 megapascal. And then we got the solid acid, which was washed with water for 3 times. Thank you for your attention.
Thank you for your presentation. Questions? Dear experts, do you have any questions for this presentation?
Yes, I have one question. How did you track the progress of the reaction?
Pardon, could you repeat it?
Sorry, can you repeat?
Can you repeat your question again? Thank you.
How did you track the progress of the reaction?
You mean this one? Track the reaction. We use in-situ UV clinics investigation. And by recording the observe at
No, I mean thin layer chromatography or high effective chromatography.
Could you repeat it? I didn't hear it.
I mean thin layer chromatography or high effective chromatography.
You mean you mean this one?
No, when you begin, you say that you used TLC, HPLC.
I know. We get the reaction liquid in the pressure tube and doing the TLC, and then after the reaction we use organic liquid to dissolve it and process HPLC to find out its details.
Oh, thank you. And What NMR spectra did you capture?
What numbers of which can you?
H1 or C13. NMR, nuclear magnetic resonance. What spectra did you use?
What you mean the type or?
No, NMR. Characterization
NMR.
of products by NMR. Yes, yes, it is.
This?
Yes.
We use HMR.
H.
This picture.
Only H.
Yes. I began to learn it and use HMR to find out its structures.
Yes, it is very important for chemical synthesis.
Yes. And as for these products, we also conduct HRMS